I'm Bob Johns. I'm director of the Volpe National Transportation Systems Center here in Cambridge, Massachusetts, and want to welcome all of you in the audience, but also welcome our webinar participants. And I know we have, as usual, representatives of many organizations around the world on the webinar. We are going to have a chance for Q&A after the talk, so we'll ask the webinar participants to type in their questions as well as take questions from those of you here in the audience. This is the 8th and final event in our series on transportation system resilience, extreme weather, and climate change. It's been a very energizing series for us here at Volpe, and we have had great participation on the webinar, as I said. And we're very pleased today to have our final speaker be Dr. Jerry Melillo, a distinguished scientist and director emeritus at the Ecosystem Center of the Marine Biological Laboratory in Woods Hole, and a professor of biology at Brown University. And he's a great one to end this series. I'll describe just a little bit of the work he's done. He specializes in understanding the impacts of human activities on the biogeochemistry of ecological systems from local to global scales, using a combination of field studies and simulation modeling. In 1996 and 97, he served as the Associate Director for the Environment in the U.S. President's Office of Science and Technology Policy. He was just telling me how Al Gore would be in touch with them weekly on some of the climate things that were starting to be understood back then. He's published more than 250 peer-reviewed articles, 2 ecology textbooks, and 3 edited volumes on biogeochemistry. He was a convening lead author for each of the first 2 Intergovernmental Panel on Climate Change assessment reports and has led 2 assessments for the U.S. Global Change Research Program on the impacts of climate change on the United States, the first published in 2000 and the second published in 2009. And he currently is chairman of the Federal Advisory Committee overseeing the design and production of the U.S. Global Change Research Program's ongoing assessment activity. He has been working on the 3rd assessment, and that's what we're going to hear about right now. He's going to speak on the 3rd National Climate Assessment, Lessons Learned, Paths Forward. So please join me in welcoming Dr. Jerry Melillo.
Well, it's certainly a pleasure to be here. I wanted to announce that I took the bus up from Woods Hole this morning, public transportation. And the subway over, and perfect, you know. No hassle, except that another Bonanza bus had broken down on its way up. So we got all of their passengers as well. So we had standing room only for part of the trip. It was very exciting. Children, and quite an amazing trip. So, thank you very much for having me here today. Ellen contacted me many months ago, and I kept on trying to put her off about coming. She's certainly persistent, which is great. And the reason I was trying to put her off is I had hoped that the assessment report would have been publicly released, and I would be able to give a very different kind of talk to you today about the findings of the report, et cetera. So, I hope you understand that we're embargoed, as they say, and we're looking at a public release, hopefully within the month. We're negotiating now with the White House about exactly how that will be done, but I expect that a month from now, my job will be done with the National Climate Assessment, and it will be out in public. So in this presentation, I'd like to do 4 things. First, I want to talk briefly about the assessment process, past and present. As was noted, I've been involved in the National Climate Assessment process for a number of years, and so I have some history in my head about the assessment process, and very interested to observe how it's evolved. And I think you might find some of my comments in that area both interesting and maybe useful. Secondly, I'll give an overview of the report and speak in very general terms because of the state at which the report is in about the findings. I won't talk a lot about the transportation chapter. That might be Coles to Newcastle, and besides, I don't want to give away the punchline. So, but I will refer to it. Third, I want to highlight one of the more important parts of this assessment relative to the first two, and that is the effort put into thinking about adaptation in this particular report. It really pervades all of the chapters, and there are some very insightful comments that the report will have to make about adaptation currently and going forward. And then finally, I'll share with you a vision for a sustained assessment process that the Federal Advisory Committee and federal agency members have been developing over the past 2.5 years as we thought about going forward to 2017, which is the next time one of these reports should be coming out. So we have a mandate, and you're all probably very familiar with this, the Global Change Research Act of 1990, a really interesting act, and among the many things that it had suggested be done were these periodic assessments of our understanding of global change, and in particular climate change. And it had some general guidelines about integration, evaluation, and interpretation of the U.S. Global Change Research Program's activities. At that point in the 1990s, U.S. GCRP was just a small entity. It's now evolved, of course, to a multi-billion-dollar enterprise within the federal government. And interestingly, it called out a number of what they referred to as sectors that the assessment should focus on, sectors that are important to the nation and to our people, including agriculture, energy production, and use, land and water resources. Transportation was particularly called out, human health, et cetera. And so these were this kind of going-in proposition of what framed that first assessment. And there were two time horizons that were identified. A relatively near-term time horizon for projections of climate change and its impacts into the future. That was the 25-year time horizon, and then there was a longer time horizon, the 100-year time horizon. So that basically is our license to do our work. And it's congressionally mandated, and our report ultimately goes to the president and then is sent on to Congress. And Congress takes a very serious interest in this activity. And the interests vary, but they take a very serious interest in the activity. So as was mentioned, the act was passed in 1990. The first assessment did not appear until the year 2000. I had been at OSTP in the late 90s, and there was a lot of talk about doing an assessment. It was about time. And as I was leaving office, the President's Science Advisor said, "How would you like to help do this?" And you don't turn down an offer like that. So I was one of three co-chairs, one federal scientist, Tom Carl from the National Climate Data Center, one person who at that time was working for an NGO, Anthony Genados, who was working for World Resources Institute, and I was the academic in the group. In 2000, we produced a short report and a long report. The long report is the blue one over on the right, many hundreds of pages, very scientific in its writing, and a short report that we engaged a science writer to help us with, and hopefully it was much more easily read. Then there was a quiet period with the national assessment during much of the Bush administration. Towards the end of the administration, however, the second administration, we were asked to help produce a second assessment. So the second assessment, which came out in 2009, started under the Bush administration and was issued under the Obama administration. The first assessment started under the Clinton administration and was issued at the very beginning of the Bush administration. So these were interesting bridging times. So here we are. Now, about 3 years ago, a federal advisory committee of 60 members was formed by NOAA, and 44 of the members are non-federal, 16 were federal, and we undertook the design and production of the third assessment report. We used an IPCC-like model. We identified a set of authors for each of the 30 chapters that the report would ultimately have. As per IPCC style, we had a pair of convening lead authors, a set of lead authors who made major contributions, and then there were also some contributing authors to the various chapters. This effort has been larger and more inclusive than the first two, and there was extensive, and I mean extensive, pre-report preparation with a whole series of scoping workshops on a variety of topics, a lot of stakeholder interactions to identify practitioners who might join the author teams, which was something new in this assessment. Historically, we had some practitioners involved in the authoring of the report, but this time we have quite a large number. There is also a lot of evidence, and you'll see that in a second, of public-private partnership. The business community who stayed away from the first two assessments became willing to join this third assessment. We found that very gratifying because we think that public-private partnerships are essential going forward in the assessment process. And with these 300 authors, we were able to represent a wide range of expertise in a host of really important topics. And I just give you an example of the 3 chapters related to climate responses, adaptation, mitigation, and decision support. They're standalone chapters in the 30-chapter sequence. And this is the range of public and private sector authors. Homes, I didn't put their names up there, but Homes, and you can see it's a really kind of an interesting mix of people. And to be in some of the discussions of each of these topics was absolutely fascinating because people brought very different perspectives to the fore about how the chapters should be shaped, what should be in, what should be out, and so on. But this was quite typical of the report as a whole. So let me talk a little bit about just the outline of the report. As I said, there are 30 chapters. We start out with sort of introductory material, an overview of the entire report, and a listing of 12 report findings. We basically boiled down this report, which, if it were printed, the full report would be 1,400 plus pages and 30 chapters. And we attempted to distill all of that information into 12 major report findings, and the report findings were heavily debated and decided upon by consensus by the Federal Advisory Committee. And so there are 60 people, remember, and one of my tasks was to bring consensus to the wording. It's kind of like the IPCC executive summary process. But I've got to say, the Federal Advisory Committee was really terrific, and They were extraordinarily helpful, never obstructionist. It was just a wonderful process. So we have these chapters, a very extensive chapter on our changing climate with a focus on what is new since the 2009 report. And interestingly, we share a number of authors with IPCC so that there is a good mapping, but not a complete mapping between what the IPCC report says about climate science and what this report says about climate science. And of course, the IPCC report is global. We are focused on the US, conterminous US, Alaska, Hawaii, Puerto Rico, and the Pacific Islands. And so there is more texture at a higher resolution. We have a series of chapters on the sectors that I showed you before, including transportation. And then we looked at some sectoral crosscuts, interested in climate, energy, water, for example, as a cross-cutting, interacting activity. We also have a set of regional chapters. In the first assessment report, we were originally not going to deal with the regions, and we went to Congress and told them what our outline was. And they kept on asking, well, what about my place? And so we amended the outline and added a very interesting regional perspective. We also have some biogeographical crosscuts. For example, if you look at that map there, which is the cover of the report, those big black lines sort of demarcate regions. They're a little peculiar. West Virginia sort of slips into the northeast. I don't know whether it's Civil War memory or something. The southeast is a big chunk. Texas is part of the southern Great Plains, but coastal Texas also is considered part of the southern Great Plains. There was a lot of pressure to keep political boundaries, so we had to overcome some non sequiturs, and we felt that, for example, a cross-cutting chapter on coastal ecosystems would be appropriate, and that would capture coastal Texas, for example. Beyond the regions and biogeographical crosscuts, we have 3 response chapters: decision support, mitigation, and adaptation. We have a chapter on research needs going forward, and we have a very short chapter on a vision for future assessments. And we have also produced a special report that has been submitted to NOAA about the greater detail that we envision for a sustained assessment process, and I'll touch that at the end. And then there are a series of appendices. There is an excellent climate science primer that augments the climate science chapter. There is a discussion of scenarios and models. There are frequently asked questions, et cetera, et cetera. So this is the nature of the report. Just want to give you 2 more process slides. One has to do with the review process, which has been extensive. We had a first draft that appeared in public in early January of 2013. The public had 3 months to review the public draft. They took their job very seriously. We received more than 4,000 comments on the draft, and we took each one of them seriously. We have responded to each one, incorporated them where we thought it was appropriate, and tried to explain when we didn't incorporate a comment or an answer to a comment why we didn't do so. And all of that information will be made public. This comment period was actually very interesting. We had a long debate as to whether or not we would allow the authors of the chapters to see the names of the commenters. And we thought that that was inappropriate because it might bias them. Oh, he always says that, or she, that's something she says all the time. So they were anonymous for the review process. They will be published at the end of the process. All of the comments will be published and people will be identified. And so we thought that that would both protect the commenters initially, but make them take this job seriously, so, because they would be known entities in the long run. So anyway, long public review process. A second draft was completed in the summer in response to public review that went to federal agencies and the National Research Council. They did a review for us as well. We acquired another 1,500 or so comments in aggregate on the revised chapter or the revised report. And then we took those comments on board and we went into a high-level federal government review period early in this year, and that review period was completed in late winter, and we're now about to go public. So well reviewed. The products that will appear will be several. The large report itself, the 1,400-page report, will be only in digital form. But given the way people use information, we think that that's totally appropriate. And it will be in a form that will allow you to click and chase. So if you're interested in a data set, you'll be able to click on that and then trace it. And ultimately, if you're interested, get a hold of that data set. So we're trying to make access as easy as possible. But it will only be digital. We have produced a highlights of that big report that will be both printed and digital, and very much like the short versions in 2000 and 2009 of those assessments. And it is totally derivative of the parent report. It has also been extensively reviewed, and it also, of course, will be digital. From our first experience in 2000, we learned that even shorter summaries were useful. And when we went to the Hill, we had a number of requests for a 20-page summary and a bunch of 2-page summaries about the regions and so on, and so those will also be done. So there'll be a variety of products, including slide sets and so on, that people can use for presentations on the assessment. Okay, now here's the tricky part. I can't talk about the report findings in great specificity, but let me just give you some very high-level perspectives on the report findings. There are several report findings about climate science that are at the highest level not so different from IPCC's recent science report. The approach that the authors took was a very holistic approach, looking at the climate system writ large, including the land surface, the atmosphere, the oceans. As they talked about evidence for climate change, they talked about evidence in all of these components of the climate system. One of the super strengths, I think, of this particular assessment was the extensive regional analysis of climate trends. We started several years ago going region by region, trying to document very carefully what had happened in each of the regions. And this is a very different kind of information set than any projections that you might make, because this actually happened in your place. And people are very interested in that because they think they observe well. But in fact, you know, it was last year's cold spell, or 2 summers ago in Texas, it was the heat or whatever. So this, I think, is going to be extraordinarily valuable. And we are now getting requests for this information to be downscaled even further to the state level. States would be very interested in knowing what their climate history was in quite extensive detail based on national records as well as their own. So I think that's a particular strength of this assessment. Another particular strength is the analysis of extreme weather and climate events, and where possible, their links to climate change. And some of the areas highlighted are prolonged periods of excessively high temperatures, like Texas in 2011, for example, which I'll show you in a bit. Heavy downpours in the Northeast, were the epicenter for heavy downpours increases over the last several decades, and then more severe droughts in some region. And the science is evolving in attribution of these events and climate change. So this is a cartoon of kind of the holistic view of indicators of a warming world. The up arrows are increases, and the down arrows are decreases of whatever the entity is. And then each one of these is talked about and at the global scale and what kinds of evidence we have for each of them. This is some of the temperature change data that is a bulwark of the report and is heavily used by many of the chapters across the report. Again, those heavy black lines demarcate the regions. This is a picture of temperature change over time relative to a reference period, which is 1901 to 1960. And so as you march around, the map up in the upper corner is the US average, and then you can go to any of the regions that you're interested in, and when you click on those, you'll be taken to data sets. So that, you know, I don't know what your climate memory is like, but these are the trends according to our national statistics at the National Climate Data Center. And these particular changes that we're showing here are especially focusing in on the past 22 years or so, so that the last bar includes a 12-year time period, not just 10. We also show Alaska and Hawaii. The climate records for both of those places is less long, and so they have a different reference period. But you know, there are some interesting things that emerge, and you might understand why people in the Southeast would say that there might not have been as much climate change as people in the Northeast, Alaska, Southwest, and so on. There is texture to this data, and it's important to recognize that. High temperatures. This is heavy precipitation events and the change in heavy precipitation events for the period 1958 to 2012, when they think they have really good data on this. And the Northeast has a striking 71% increase in heavy precipitation. And I'm sure that each of you has a story about this. My story is that I was driving from Yale back to Woods Hole through Providence in the spring, I think it was 2010, when there was an extraordinarily heavy rainfall event. I couldn't see 20 feet in front of me. And I was on 95 just to the west of Providence, and it became a one-lane road. I got behind a 18-wheeler in my little Subaru Forester, and he kind of parted the waters, and I sort of scrunched up and drove right behind him, got to the other side of Providence, listening to the radio, and I-95 was closed. You know, just a heavy precip event, and all of the reasons why the infrastructure was not able to manage that kind of an event were really very obvious. So the eastern half of the country is showing this pattern. It is significant and well outside of natural variability. The western part of the country, not so much. And in fact, most of the information in the Southwest, Hawaii, Pacific Northwest really is not outside of the range of natural variability. But the East certainly is, and projections are that it's going to get worse with time. This is interesting, and this is kind of cutting edge and hotly debated science. So there are two figures here. The one on the right is an example of how extraordinary the 2011 summer in Texas was. This, if you look at the graphic, look at the axes, this is a June through August average temperature on the y-axis, and the June through August total rainfall. So it's a phase plane plot, and 2011 is here. Everything else, including the Dust Bowl period, are in that cluster. And this is just a coast-to-coast 100-degree day map in 2011 as well. And here is the area that we're talking about. And the climate scientists at the National Climate Data Center think that they can detect a clear climate change signal for this particular event, not every event, but this particular one. And they think that climate change increased the probability of that 2011 anomaly by maybe a factor of 2. And at least probably 50%. But that's still science working. But the projections are that that 2011 anomaly is not going to be that unusual towards the end of the century in certain parts of the country. Okay, there are a series of projections about climate made in this report. The projections are based on scenarios. We have both climate and sea level rise scenarios, and they are separate. The climate scenarios, which are the workhorse scenarios for the report, are the old ESRES B1 and A2 scenarios. B1 is the lower scenario, but with no policy implementation, and A2 is the higher of the scenarios. And they're from the old CMIP3 model intercomparisons. As we were moving into the assessment, we were worried about whether or not we should be using the new IPCC CMIP5 scenarios, but they were absolutely new when we started out our analysis. And so we convened a group of climate scientists and said, okay, we have a problem. We don't want to put stale bread on the table 2.5 years from now. So what do? Do we take a chance and use the RCP new IPCC scenarios, or do we use these older scenarios that have been applied to a number of impact studies and so on? And they said, we think that you should go with the older scenarios. The new ones are not well understood. This was 2.5 years ago. And so we went with the ESRES scenarios as our primary scenarios. Since that time, however, the RCPs have sort of crept into the report, and we try to do a mapping between ESRES and RCPs so that the public can understand them. And we report, in some places, results for both. With respect to sea level rise, it is not sea level rise as projected by any of these scenarios, but an independent analysis of sea level rise in a risk-based framework. And I'll show you the results of that in a second. But we're basically scenario driven for projections. This is a graphic showing our workhorse scenarios, the B1 and the A2 as projected out over time. And out here we're showing some other, another ESRES scenario. Notice that there is variability in each of the projections associated with how the models deal with various details of the climate system, including clouds. So this is our workhorse set on your left. Over there on the right are the new IPCC scenarios that were used in the most recent IPCC report, the representative concentration pathways, the RCPs. We show the bookends here in this graphic. The RCP 2.6 actually has a significant policy component involved in it. The RCP 8.5 is kind of a business as usual. And if you look at this, and we do a more detailed job in the report, obviously, is you can basically map the RCPs and the ESRAS scenarios. And in fact, A2 and ESRAS A2 and RCP 8.5 are quite similar. And they, in some of the chapters, are used interchangeably. Our lower scenario, the B1 scenario, is most closely related to the RCP 4.5. And so in the chapter, we do that kind of mapping. We didn't put all of the lines on here because with the 95% confidence intervals, you can't read the graphics anymore. Anyway, we used those scenarios, and then we began to think about issues of uncertainty associated with these scenarios. And I picked a particularly tough example. Temperature is an easier parameter for projections, and you get greater agreement across models. Precipitation, however, is a real challenge. Quite difficult to represent in these models. And what this graphic is showing is sort of end of the century, last 20 years or so of this century, projected precipitation by season with the high emission scenario. So this is kind of business as usual, and we are on the business as usual track plus right now as a global entity. So, take a look at this and look at the various regions, and let me explain the color scheme. The brown shades are decreases in precipitation as projected by 15 or so climate models. The blues are increases. The darker the blue, the greater the increase. The white areas are inability to distinguish a change from natural variability. So these models said, we just can't tell you for this big white area what is going to happen. And so that's very interesting, that there is a substantial portion of the United States where the precip issue is in question. The other thing to look at is the hatched areas. And the hatched areas represent high agreement across the various models. And so, kind of the take-home message is the wet areas are going to get wetter generally, the dry areas are going to get drier. There's substantial uncertainty in our ability right now to predict precipitation in a significant belt across the middle of the country. And the seasonality is also very interesting, especially if you're in agriculture, because sometimes of the year it doesn't matter so much, and other times of the year it matters tremendously. And so this kind of information is very useful, and this is one of the ways we tried to represent the uncertainty in these projections. Here's sea level rise, something that is clearly very important for transportation, all of the coastal infrastructure associated with major cities and so on, military installations, et cetera. And the report, as we did in the public review document, indicate that our projected range of 1 to 4 feet is still holding in our estimates of sea level rise globally. As we all know, relative sea level rise from place to place varies significantly. But the other thing I want you to notice, and this, by the way, is not so different a range if you read the IPCC report and look at the detail of their presentation of sea level rise. They go They're high and is very close to 4 feet in the end. But there are these light gray areas that derive from a scenarios analysis done by NOAA that suggests that if you're risk averse and you recognize the uncertainty, especially at the high end, associated with glacial mass in Greenland and the Antarctic, a worst case scenario for this century might be over 6 feet. And so it's a risk, kind of a risk-based presentation. And we're very explicit in the report about how we think about this, but this certainly is sobering. And there have been a series of recent papers that have used satellites to map ice mass in both Greenland and the Antarctic. And those masses are declining even a little more rapidly than we would have projected. And you see all of the calving, the dramatic calving, but the overall mass is what you want to keep your eye on. Okay, there are a whole range of report findings on impacts. Just moving on from climate. Human health, water supply, agriculture, and infrastructure. These are aggregate report findings. Some of the sectors are called out uniquely, like agriculture. A sector like transportation is combined into an infrastructure report finding. You will recognize, I'm sure, a number of the names of the authors, and you will certainly, I think, agree with many of their findings, I would hope. But we've actually called out these and some additional impacts, and two of them that are really very interesting and done, I think, better than ever before include the benefits that ecosystems provide to society, the ecosystem service concept. And one of the important services that is highlighted for ecosystems, including important coastal ecosystems, is the capacity of these systems to buffer extreme events. And when you lose those systems, you lose that buffering capacity. The other important point that is made throughout the impacts sections of the report is a focus on the interactions of multiple stresses. Climate change occurs in the context of a bunch of other things, whether it's acid rain or land use pressures or whatever it is. And we've tried to bring that perspective to the fore. I was really upset the other day to read an article in The Economist about the second of the 3 IPCC reports. And their take on it was, well, climate change is only one of X number of important stresses, and therefore it may not be as important as we thought it was. Seems to me a strange conclusion, but there it was. The other thing that we've done for the first time in this report is actually focused on the oceans. We have an oceans chapter, and we talk about warming and acidification and their interactions, and what this means for food web structure in the ocean, what it means for distribution of fisheries, and so on. And we also highlight how the warming and the acidification interact with other stresses like coastal eutrophication with nitrogen, for example, to really upset the ocean as a system. There are report findings on both mitigation and adaptation. The mitigation findings basically document what has happened and also point out the alternative projections of emissions and what the consequences of those might be for the climate system. But it is not a policy prescriptive chapter because that is out of bounds. The adaptation chapter is, I think, particularly well done. And it begins to catalog and to categorize a range of adaptations, and they basically worked with the authors of the various regional chapters and some of the sectoral chapters to include adaptation in each of those chapters. So it's a really interesting treatment of adaptation across the report. And in both the mitigation and adaptation chapters, the point is made that there are significant links between mitigation and adaptation, and more mitigation can imply less need for adaptation. And we also make the point that adaptation does have limits. It is not the forever answer, especially under severe climate change. Just let me talk for a minute or two about adaptation in regions and sectors, and we just pull out a series of examples of the kinds of things that are being done, everything from rezoning to ecosystem restoration to this example from the transportation chapter, where they've sort of laid out a typology thinking about climate changes, impacts to transportation, consequences for people, because climate change is a lot about people, and then the opportunities for adaptive strategies to reduce impacts at both of these transition steps. And I think this is very, very nicely done, actually, and the discussion of it is terrific in the chapter. The adaptation challenges are obviously many. One of the take-home messages from the adaptation chapter is a lot of planning, some action, a lot more action needed. They point out that very often adaptation is done for reasons other than climate change. So there's a win-win aspect to that, which is important. They point out that you want to consider this concept of multiple stresses when thinking about adaptation, and you want to look at the composite threats as well as the trade-offs among costs, benefits, and risks of available options. So they're trying to sort of lay out the complexity of this situation, and you all probably are steeped in this every day because there are clearly trade-offs and costs and so on. And then finally, there's a call for more effort to evaluate the effectiveness or the efficacy of any type of adaptation. This is really tricky business because a lot of it is anecdotal and it hasn't been around for that long. So are we going to recommend that this action work? Well, we don't have a whole lot of evidence quite often for that. And I think it's probably particularly tricky in transportation where a lot of your investments are capital investments that have a lifetime of decades to half a century or more. So let me just close by saying that there is basically a white paper that has been submitted to NOAA, and you can go to the U.S. Global Change Research Program website and pick this off, Preparing the Nation for Change, Building a Sustained National Climate Assessment Process. And the idea is, there are a number of components to the idea, but the idea is that we don't sort of stop and start assessments every 4 years, but you kind of keep a rolling activity going that does many things, including building capacity of people to use the information that the climate assessment is producing. And it is particularly aimed at practitioners at various levels because they're the ones that are going to be interpreting the science, et cetera. The notion is that there are a whole series of foundation investments that you might want to make. You might want to pay much more attention to developing scenarios and communicating those scenarios very carefully. There's a major effort in the U.S. Global Change Research Program to develop a global change information system that provides access to a lot of this data. And if you can build the capacity of people to use the data, then it's truly a win-win. But that effort is going on. We just produced an indicators report for the U.S. Global Change Research Program indicating that we think that there should be a set of indicators that keeps track of change that is basically reliable and bought into by a wide range of users. And then finally, there is a major move afoot to promote partnerships, public-private partnerships that would encourage the use and interpretation of national climate change information. And we've started a network, we call it NACANet, and it has a URL down at the bottom. And we currently have about 100 members of this NACANet organization, businesses, NGOs, academic organizations, who are getting together to think about how they are going to use the National Climate Assessment, how they're going to help communicate it, and what kinds of projects they might want to start on their own. And I heard about a neat one that's going on here, by the way, which would be a perfect NACANet example. Well, I'm running well over, sorry. So I'm going to just move to the very end and say that one of the concerns that we've had throughout the National Climate Assessment is, how do we know that the assessment has been a useful exercise, and what kind of metrics would we select to test the usefulness of this exercise? And so in about a month's time, we're going to have a meeting where this will be the primary focus. Once the assessment is released, we're going to start to think about how you do the follow-up evaluation. So within a month, it should be public. You'll have access to it all. And again, I apologize. I could not go into the gory detail of the science and its findings. Thank you very much.